and a half, and then I went to Google, where I've been for about a little over 8.5 years now. And at Google, I've kind of moved around a bit, which is kind of common at the company. You can actually, once you're there, it's pretty easy to move to different areas. So I started in Workspace, which is the team, like that produces Google Docs and Gmail and those types of those products. I worked at Google Fiber very briefly, and then they kind of restructured the whole company, and then I moved over to Google Cloud. Google Cloud is basically like public cloud infrastructure. You've heard of like Amazon Web Services, kind of the market leader in that space. So I was there for a really long time. I went to our like data infrastructure team for a bit, and then earlier this year I moved to our basically machine learning developer team, so focused on tools for developers building machine learning systems. And so the products there are Kaggle and Colab, and then the Gemini API, if you want to build things on top of Gemini models, and then there's an AI Studio, which if you haven't used AI Studio, that's a pretty cool product actually. Okay, cool. So let's step back and talk about like what is data science. Are people familiar with the idea of data science, the term data science? I love your shirt, by the way. Oh, yeah.
Thank you.
I saw that. I was like, yeah, agreed. Yeah. And so, I mean, data science is kind of a young field, right? It used to just be called statistics or sort of high performance computing, maybe a part of it, like analytics, a lot of different things that have become under this like formalized the idea of data science probably in the last, say 15 years or so. The term was sort of coined in like 08, 09, when people started calling it that, but most people at that point were data scientists, had like PhDs in statistics actually. And then they knew how to program, but they were really statisticians. And so generally the way I think of data science as using programming as a tool and statistics as a tool to study complex systems. I mean, this is pretty broad definition. I would add the caveat that the thing that's really like unique about data science and the role that it has in practice is systems that produce a lot of data, which is when you're in, this is the reason technology companies tend to have a lot of data science, because technology companies generally produce a lot of data, and then they have to, but every company does, and every system does. I mean, a lot of what's sort of more traditional science would really classify as data science in a lot of ways. I mean, physics, if you're doing kind of theoretical, experimental physics, and you're tracking like like particle detectors and this sort of stuff, it's very similar in a lot of ways. And that's kind of my background. So I came from sort of behavioral neuroscience, but I was really tracking like multi-channel time series data, and then looking at signal there and trying to understand behavior, mapping between behavior and the brain. Now I kind of try to like look at metrics that describe behavior, where are users running into problems and things like that. Cool. So when I think about data science, I kind of think there's sort of this technical pillar in the middle, technical skills, which would be programming, knowing how to code. Generally speaking, most data science, depends where you are in it, but most people don't have like software engineer level like programming. Like I'm a pretty good programmer, but I shouldn't really be a software engineer, but I'm a decent programmer, right? So it's slightly different like strength, but then there's this breadth across all these different areas. So statistics is really the other really critical skill, is being able to think statistically, understanding statistical approaches to questions. So there's that, like that's really the foundation, right? If you have those two things, you're gonna be able to do analysis in data science. And depending on if you're more on the statistics side or the more programming side, you could be more on the data engineering side or more like purely analytics or business intelligence side. And then across the breadth there, most data scientists have some level of subject matter expertise, right? So in my case, I'm a behavioral neuroscientist, like by background, and so when I come and study problems, that's kind of how I think about it and what I sort of do. And then there's this, and then I think what all data science kind of have is this sort of scientific method or analytical approach to breaking down problems, right? And so that's kind of like the, I don't know, there's like the technical pillar, and then there's kind of the foundation that flavors kind of the types of questions you're interested in, how you approach those questions, and that sort of thing. There's another one that's actually really important, and which is communication, actually, and being able to explain, because a lot of times the data scientists, you're talking to folks who don't have the subject matter expertise, or they don't have the statistics, and so knowing how to explain these types of concepts and how you approach problems, so to people who don't necessarily have that same foundation is really important as well. So a lot of times I'll get a request where somebody says, oh, I want this number. I want to know how many people do this thing. And it's then it's well, okay, what do you actually want to understand? Let's unpack that. So that's a common thing. Okay. Any questions at this point? I don't know. Is this making sense? I don't know.
Yeah.
Okay. Cool. Great. So I'm not going to go through all this. We can do this in questions if you want. I'll just show this up there. But Google, has been around for, Google's been around for that long, but it's been around long enough. It definitely predates data science as like a cohesive like role. And so there's like, but this isn't even all of them. This is kind of on the more technical side of things. All the different roles that I would kind of consider data science at Google and the types of things they do. So I'm in that like, I'm this role. So like my specialty is really trying to help teams understand user behavior at scale. So how do you understand the behavior of millions to potentially billions of users across the system? Where are people running into problems? When we launch something new, is it working well or is it not working well? How are people doing with it? So that's a lot of what I kind of have these like, this lower line here is like the punch line of like what these different roles are for, and then the tools. I can share these also. So like I think my job is a lot of times about generating hypotheses. How do you measure things that are somewhat unmeasurable? Like the example I always give is somebody wants to measure like helpfulness. How do you quantitatively measure helpfulness? It's actually not, it's not so straightforward, right? If you want to just measure something like revenue, okay, that's pretty straightforward. And so the other roles would be like data scientists, used to be called quantitative analysts. That role is like, basically that's the formal old school like statistician who comes in and they basically study these statistically really nuanced problems. Most of them have a PhD in statistics, but not all. Product analyst has changed names, actually I forgot to update that. But basically they're sort of they're focused on business or product insights, kind of like how is the business doing, how is the product doing. Software engineers, so at Google the folks who build production models and actually deploy them out. So yeah, if I'm using a jargon, please raise your hand. Like I'm kind of like in the jargon world, so please raise your hand. But like production model would be like, well, there's things like the big LLM models, which I'm sure folks are familiar with, things like GPT and Gemini. But there's also a lot of smaller models that people put out, things like spam filter models, things like that. So if we go skip one, research scientists are generally, they're almost like faculty members. They're really computer science researchers that then are at the company and studying things. So their role has changed a little bit in the last couple of years with the push for LLMs, but they basically are like academic. They're trying to publish papers. They're trying to move forward the actual fundamental science. They may do things like working on how do you build massively globally scaled computing systems. So that's something the research scientists work on. A lot of them are working on machine learning now, and have been for a long time. I mean, the foundations of large language models were really created at Google by research scientists. Foundation can go back a long ways, but 10-ish years ago. And then software engineers, though, will be the ones who actually like create the models that go into production, which at some companies would be a data scientist role as well. Okay, this was maybe a lot, but I'll share this out. If people have questions, we can talk about it. I'm going to just do one little vignette of some sort of work that I've done. This is a little bit of a while ago. But the question is, so Google Cloud Platform is our public cloud computing. You can do things like set up a virtual machine, you can do storage, you can run BigQuery, you can do all kinds of different things. Anything you can do on like a computer, on premises, it's largely for like server type stuff. Anything you can do on a computer you can basically do with GCP, including very advanced things. And so the problem is it's super complicated. There are like 200 products within this space. And most people, to solve a problem, like if somebody wants to create, say, an e-commerce site, e-commerce system, right? They could build all of that here, even at the scale of like a major retailer. So like, a Target or a Home Depot could build their entire system on top of GCP. The issue is that's very complicated. And so what we were trying to understand is how do users actually behave and integrate multiple products together to solve the sorts of complex problems that they have. And so, what people will often do is they'll segment users on their behavior. The problem is there's a huge space of actions that people can take, right? You can like, just in the virtual machine, you can create a virtual machine, you can deploy an image to it, you can modify it, you can delete it, you can reboot it. There's all these different actions you can take. A lot of the tasks that people do take a lot of steps. It's not like, so if you're writing an email, you read an email, you think about it, you respond to it, you send it. Like, it's 3 or 4 steps, and they're pretty stereotyped, right? The more complex things in something like Gmail would be like, okay, maybe you need to set up a vacation responder, or you need to set up like grabbing your email from a client or something like that. There's some complex stuff, but most of the things people are doing are pretty simple. Whereas if you go into these like enterprise systems, so many things people can do, and what that winds up being is if you think about, okay, how many people do this thing? Well, in Gmail, it's like, oh, there's 3 steps. So there's only so many ways you can do that, right? And there's basically a defined order in it. In GCP, there's so many different ways you can do things and orders you can do them in, and it starts to be 10 steps, so an enormous number of actions. you start to look at sequences. So people like, I don't know if you've seen like a funnel analysis where somebody comes into something, how many people do this next action? How many people do the next action? So it's used a lot for like e-commerce or like people coming in to buy something. How many people add something to their cart? How many people add something to the cart? Like how many people actually buy something? This kind of analysis totally breaks down when you have such a large action space and also so many steps that people take. So that's kind of what I mean. Most tasks require many steps, can be done in various orders, and then there's many permutations of that action space. Like basically, you can't really look at just sequences. And so the kind of what we decided is let's ignore the fine temporal structure. Let's not worry about if they did, equivalent would be we don't care if they wrote the email before they sent it. Like that's effectively what we were saying. We're going to say, did they both send and write an email? Because there are cases where you could actually send an email without writing it. You could just forward an email or something like that. But in our case, there's many, many different orders you can do things in. And so this is what we did. I have you have questions on it, but like you basically transform the data, train a model on it, and then use that model for kind of clustering the users, and then create visualizations to explore the data. So I'll show you some stuff. This is like a visualization of all the users within the system in this like two-dimensional space. And so we can then can we look closer? So here are two areas of interest that we can dig into, and we can basically, so these are color-coded by products. I can tell you these users are doing mostly like VM management, networking, and maybe a little bit of storage. And then these users are doing almost largely storage and some things related to that, right? So it doesn't really matter necessarily, but then the idea is within these segments, we can start to think about what are the common behaviors that people have, understand the problems and the opportunities that they represent for the product team. Here are my collaborators on this. And then some other things. Basically, our job is, like I said, study user behavior at scale. So some of the other things that people have done is understanding the volume and context of user-generated content in maps. So this is something that Google put a lot of effort into maybe 5 or so years ago. And Gregory is one of the people who kind of drove that, is understanding there's actually, Google Maps used to not have that much review data and user-generated stuff. And the idea is, well, if hours are wrong on a business, people can inform that. If they see the hours are wrong, they can actually go in and say that. And so this is, and then of course there's the more conventional reviews and things like that. This is an interesting one. So here's kind of the sequence analysis. In this particular product, you can actually, that's YouTube, but YouTube, especially back then, didn't have that many actions people could take. And so you could actually think about the actions they spawn up. You can actually think about how many people are doing this or that or this, and so, this or that, and what are the things that are associated with people coming back or doing particular actions. And this is a case of the opposite of what I did, where she actually did a nice visualization for exploring explicit sequences. So everybody starts in this green one, and then some people do that again, some people go to the yellow, and some people go to the red, and so forth. And then here's another interesting one where looking at people self-emailing, and could we build a product around reminders that people actually they're doing self-emails so that they regret doing something or giving themselves a task. Cool. So yeah, that's what I've got. I'm happy to answer any questions. Yeah. Cool.
Our next guest is Reuben. Let me find his slides in all of my chats.
Alright, so I didn't exactly have time to prepare the same slides that Red did, as you guys can see. What I did was, this was our introduction slides for GIR, so I just repurposed them so that we can talk about it. And let's get started, shall we? My name's Reuben. Some of you have met me. For those of you who have not, I am the GIR at Tennessee State. And me and Jessica are both doing the GIR program this rotation. A little about me. I graduated from UC Riverside. UC Riverside is in Riverside, California. And I went there for 5 years. I did computer science as a bachelor's. And then pandemic happened. So let's just say during the pandemic, I saw an opportunity to complete my master's in 1 year. I took it. And here we are. And my master's, and that's actually my parents coming to visit me, mom and grandma, for graduation. It was also the first time we were able to do the graduation since the pandemic, so they were able to finally fly in. And yeah, a little bit more about me. At UCR, I was part of GameSpawn. GameSpawn is the game dev group on campus. And I have worked as a training game dev, so just practicing it, for about 3 years nonstop. I also was part of ACM at UCR. ACM is the Association of Computing Machinery, which is essentially a computer science club. And I was a member for it for basically ever since I came to UCR, so the freshman year. And then, yeah, after college happened, I started applying everywhere. Google decided to extend an offer. I started applying at the end of my 4th year. So, roughly when I was beginning to do my master's, I would technically have a full-time. I wanted to have a full-time job after my master's. So I started applying everywhere. I think I got back from Meta, Amazon, and Google. Amazon gave me one round of interview and then never replied back. So. You Amazon. But to be fair, I also did not want to work there. If you know, the working environments are not exactly humane. Even for software devs. Yeah. I'm not going to slander another company while I'm standing here. The other options I had were Meta and Google. Meta, I got to the final round, but they did not extend an offer back. Google, I got to the final round, they extended an offer back, and well, here we are. I interviewed right when I was in my master's course. I think I interviewed Jan 10th, roughly around that time. Got through my interviews, and they extended an offer for me to work full time in Seattle under Google Cloud. So I took the offer, and then start September 2022, I started working full time as a software engineer in Google Cloud in Seattle. So there's the Google Cloud logo for that. And I've basically been on the Fleet deployment platform team. This is our new rebranding team name. We've changed multiple times. We started as the GC Fleet org, then it turned into the Fleet organization, then it turned into the Fleet host and qualifying team, and then now finally we have turned into the GC Fleet deployment platform. It's been through its fair share of turmoil. We've had our managers change, we've had the teams change, we've had higher ups change. It's been there. It's a journey. So, and essentially now, as of current, I'm obviously the GIR at TSU. But once the GIR period ends, I'm going to be going back and working with the Fleet deployment team, who I have been with for about 2.5 years. We'll be approaching 2.5 years when I go back. And yeah, a little more about me. I'm also part of the SAHM club on Google, which is the South Asian club on Google, and this is actually from this year's Holy event that we hosted. This was in March, I believe, of this year. I also play a lot of volleyball, so that's from my team that we started at the start of the season. And also I work with a lot of teaching opportunities. So this was actually a campus tour for a teaching abroad session that I did for students in Japan. I believe they were from some university in Hiroshima, I forget the name of it. Something Girls University of Hiroshima, and they came to Google, and that was basically the tour video from that. They also brought us mochi for some reason, so that was a very happy day. And also, for those of you who are curious, before I started college, I used to also play Clash Royale professionally. So before when that game actually was, not pay to win. And yeah, that's basically all about me. While I was also at college, I also did a lot of hackathons. So all of you who came to the Tech Challenge, if you were here at least a year before, you would have seen that Jake and Andrea did. Was it Jake? No, it was I think it was Andrea and someone else. Andrea and Colin. They did the Fisk and TSU hackathon, which is a 36-hour hackathon. Back in California and obviously that whole area, hackathons are quite popular. And I remember as a freshman, I did 3 hackathons in my first year. I did, I think it was called Cutie Hacks. These were all just based off random names that people thought about. Cutie Hacks was a 12-hour hackathon that I did. Then I did Rose Hacks. Rose Hacks was mainly centered for the Society of Women Engineers hackathon, but anyone could attend, so I did that one. That was a 24-hour one. And then I did Citrus Hacks. Citrus Hack is UCR's massive hackathon, which is based around the fact that there are citrus trees on the UCR campus. So that's where the Citrus Hack term came for. And I basically did those hackathons once a year, every single time it was offered. I also created some very cool projects with that. Somewhere, I don't think my GitHub is mentioned here, I have a chatbot analysis which takes Twitch chat. You guys know what twitch.tv is, right? It takes Twitch chat and then tells if someone is putting a good message or a bad message. So you could analyze a lot of emotes and then you could see if that's good or bad. A little fun project we did. Another one that's also not on my GitHub is we did Minesweeper as part of our tech challenge. We also did a game called Voltorb Flip, which is essentially just Minesweeper. We did Blackjack. All of you have been doing Blackjack for your class, right? We did that in the span of 12 hours. I think my first hackathon we did was Blackjack. We also made a PvP game in Minecraft for one of the hackathons. Very, very fun time. And yeah, that was essentially my entire journey so far. Any questions? Yes. You can start.
So your first job after graduation was directly to Google, right?
Yes. Right after my first job after graduation was Google. But while I was also studying, I worked as a student researcher on campus. I also worked as a grader for some instructors, and I also worked as a TA. For UCR, it was weird. You could only be a TA if you're a grad student. So when I became a grad student in September 2021, I did TAing for 3 months. Not 3 months, all 3 quarters.
Okay, so to students who want to land maybe a job, who want to have job experience in big tech companies, what advice would you give? Like, what are the common challenges that we as a student may face in the journey, and how should we tackle it?
Yeah, great question. So let me really just iterate to understand the question. The question was, what advice would I give to people who want to land a job at Google, correct?
Okay.
So what I would advise is, number one, practice, practice, practice. You cannot land a job without an interview unless you are a very special person or you have done very special things. I don't know the whole details about that, so I would not be able to give you advice there. But generally speaking, you need to practice and get your coding skills up. The only way you can do that is by just solving problems and getting better. I do think that our current interview system is a bit flawed in the sense that there are only so many problems we as engineers can ask other engineers for an interview question. And so what you can do for your advantage is just practice every possible problem and get better at all of them. Because over a period of time, you will notice that people just ask you the same questions over and over. I think there's a popular phrase saying, I fear not the man who can throw 1,000 punches once. I fear the man who can throw one punch 1,000 times. Because the person who is a master of something will be able to do better than someone who is a master of nothing. I would say practice is the number one thing. You guys, if I remember, I told this advice to my students, I'm also going to extend it to you. Once you are done with this class, you should have the tools to be able to solve all easy level problems on LeetCode. If you guys know what LeetCode is a website that a lot of engineers and also people who are getting into tech use to prepare for interviews. They have questions tiered along easy, medium, and hard. And they use some metric for that. I think that's just based on popularity vote. Easy is something that first and second year should be able to solve with no help. Medium is generally reserved for third years, fourth years, and interview questions. And then hard is for the sociopaths that want to just challenge themselves. So what I would recommend is, and also for those of you who do tech challenges like ICPC, the CDC for cybersecurity and what have you. So what I would recommend is all of you, once you're done with this course, go on LeetCode and start solving easy problems. Okay? LeetCode has, I think, about 2,200 problems right now. By the time I landed my interview, I had solved about 500 problems on LeetCode. And I'm going to say that's on the lower end, because my friend who landed a job at Meta did 1,500 problems.
Wow.
And you think that number is big? If you do 2 problems a day, okay, just 2 problems a day, over a period of 1 year consistently, that's 730 problems. He did it for 2 years. You see how it's very easily manageable now? You just gotta, as people say, right, the best way to go to the gym is to be consistent with it. The best way to get a job is to also be consistent with your practice. Yeah.
What is fleet deployment?
Great question, actually. So the fleet deployment, and I'm going to answer this with a bubble of this is what I think it is, because I have not been back to my team since they rebranded. So they rebranded while I was gone. Funny how that happened, huh? So basically what fleet deployment platform is, let's say you have an application on your phone. I'm going to use the example of Uber because I used Uber to get here, and it was a nightmare. If you know how getting into Fisk is, you already know how nightmare that is. So let's say that over a period of time, Uber has improved its app as we go on, right? Earlier, it used to only be able to offer you cars, not able to offer you cars, SUVs. You can, rent a helicopter from Uber for some reason. I don't know why, but you can use two. Huh? Yeah, private jet soon, yeah. So basically, over a period of time, that app has evolved into something, right? So our team's responsibility is Google Cloud offers people products, right? They offer people some services in the form called like infrastructure as a service, okay? IaaS. Google Cloud is an infrastructure that we offer to people to do. You okay?
Yes. I might ask the librarian because the room in Telegram is like not available. But keep going. You have time. Ask him the hard questions. Oh yeah, okay, you wanted a new grad to come in and talk about Google, right?
Yeah.
He's a little baby. Okay.
Thanks, Mom. Alright. Back to my point. Where were we? Oh yeah. So basically, over a period of time, Uber's app structure has evolved to the point where now you can do a bunch of things, right? Similar to that, Google Cloud used to only offer people virtual machines. Okay, virtual machines is basically a computer that we offer that you can use on a website. Okay, that's what essentially the cloud structure is. There is a computer somewhere in the middle of nowhere in a data structure, in a data farm, mine, whatever they call it, and we give you access to that for a specific fee. Okay, it's super powerful computer that can do very much powerful things, even more powerful than the laptops you hold. So, and obviously you have to pay for them. Most of it is not free. So what we do is, we have to make sure all of them are updated, correct? We have to make sure all of them have no bugs, they don't have any corruption problems, there is no, everything is running smoothly, right? There's no fire that we have set up that we can't put off. So our job is to push those services that devs all around the Google Cloud infrastructure have created and developed for these machines. Our job is to push that so that the machines can use those services. Okay? So think of us as the people who keep reminding you that you need to update your software. That's the best analogy I used for my job. Yes?
Can you tell us about your background before college?
My background before college, absolutely. So I went to high school in India, and I went there for about from pre-K all the way to grade 10. I went in a local education college, local education high school, which I think the Board of Education was SSC. I don't know how many of you know that, but that's basically what it was. I completed grade 10 there, and then I started studying for international travel. I did engineering as my field of choice, or science as my field of choice, for grade 11 and 12. I then started taking SATs and what have you, all the exams to study abroad. I think I got a 1540 on my SAT. So that ended up giving me a full ride at UCR. And I was also waitlisted for UCLA, but then I was like, oh, the fees is too much. I'm just going to take the full ride. And so after I joined, turned out UCR shot up in rankings. And now UCR is the third best computer science college in the UC system, right after Berkeley and UCLA. So pretty proud of that. And I was there throughout the whole thing. I think their cybersecurity team at UCR also ended up winning accolades while I was there, so pretty proud of that. But long story short, I took the exams, came to the US, studied in college for 4 years. Pandemic happened, started in college for 1 more year for the pandemic, and then got into Google. So yeah, basically my whole tech background.
And so what motivates you to like switch from your team of lead development platform to the GIR program?
Great question. I actually love teaching, and I feel like teaching comes naturally to me, and this is more of a college thing, especially after I took up the TA role as just for a fun thing, because I had a bunch of time on my hands and I wanted to get paid for it. So I took the TA job just out of like curiosity, and I felt like my friends kept telling me I did a good job explaining stuff. So I told them, sure, let me put this to the test and see how actually it is, and they're just not, just being courteous and kind. All my students actually came back to me after and said that I did a pretty good job as a TA. So I was like, what if I could teach a whole course instead of just being a TA to that course? And then turns out Google had an opportunity to do exactly that, so I took it. And also travel is always fun, especially when it's on company money. Google pays for accommodation, travel, food, what have you. So I saw this as an opportunity to take it, and my manager did tell me that this is obviously not productive work to the team, and promotion might get impacted and stuff. But I said, Who cares? Life is too short. You want to have fun sometimes. So I took it, and here we are. Yeah. Also gave me an opportunity to explore Nashville, a place I never thought I'd ever come before. So yeah.
Do you think it will like backfire you when you go back to your team?
I would say no. Well, at least for me, I would say no. Generally speaking, when you do the GIR program, your manager changes. So you are working under a completely new manager, and that new manager obviously provides a lot of feedback back to your old manager, saying this person is doing very well and this person is doing like very good. And so far, our manager, me, Jessica, and everyone else's manager, Lauren, has said that we're doing pretty good. So I feel like that's only positive news that can go back to my team. And also, I also heard from higher ups that a lot of Google devs use this opportunity to showcase that they have leadership qualities, because you're essentially leading a whole project throughout the year. So people also use this as an opportunity to get promoted. There's also that. A little bit of trade-offs. Do you have a question?
Yeah. So what would you sort of say is like the really fun part of your job? Like, okay, I love doing this, I do it for free, and the most stressful part, like I hate this.
The most fun part and the most stressful part. I'm going to say most stressful part is probably on-call. On-call is basically a process where, how many of you know what customer service is?
Yeah.
So customer service essentially is you get fed up with something, you call someone up and you want to vent about it, right? Essentially, that's what our team does too. Every team in Google Cloud that is a tech-based team has something called a on-call rotation. On-call rotation is basically when something goes wrong, when other teams are using your infrastructure, when something goes wrong, you are the person they are calling. And when you are the person they are calling, you're the one who's supposed to be able to either answer their questions or direct it correctly. This also applies to when stuff breaks company-wide. And let's say that there have been situations like Black Friday, like surprisingly, when also Taylor Swift released one of her songs and one of her hits was on Google, that actually broke search for a while. And the on-call team for search was, I think it came in one of our internal mails, that the on-call team for search was like overburdened on that day. So I would say on-call is probably the most stressful part. Now that we got the bad stuff out of the way, what is the most fun part about working at Google? Free stuff. We get a lot of free stuff. And also the challenges that we tackle are very, very engaging and interesting to my mind at least. So I like something which is like, it's not stagnant. I like to challenge myself, and I like to challenge how productively I can think of something. And I feel like Google allows me to express my creativity in that way, especially when we tackle problems along the field.
And so you've obviously been involved in teaching a lot, so TA through GIR, so you seem to enjoy it a lot as well. So how do you think that actually changed your perspective, made you a better software engineer?
I will say one thing, that GIR has made me a more happier person. And I feel like I blame my co-instructor for that. I will not say blame, I would say like mostly it is his fault, because he is the one who is very happy, and I feel like that's rubbing off on me. And I also feel like the main thing I've learned so far is sometimes not everything has to go right, and that's okay. You can completely, like, even today, like I just didn't mention that, we're still winging the presentation. So I feel like the understanding
Stop
that...
saying those things. It creates a negative perception. If
True.
you say those things out loud, don't say it out loud.
True, I will keep that in mind. Your feedback has been noted. But the point I'm trying to make is that sometimes I personally would always see stuff as like, I need to be the one who finishes stuff. I need to be the one who has to, like, drive things to progress. If someone tells me, can you do something, I'm always the one to say, yes, I'll get it done. I feel like GR is giving me the opportunity to also see that I'm not a one-man team, and there is a team that I can support, like I can ask for help for. I cannot be the one who's doing everything by myself. So that has been my main eye-awakening sequence so far at GR. Do you have anything to add to that? What have you?
No, they already heard my TED talk.
Fair enough. Any other questions?
Did you always know that you were gonna get into tech?
Did I know I was going to get into tech? So this is a very fun question that I like to answer by saying no. And the reason I say no is because I had a very big aspiration to be a game dev. As you can see, I was at GameSpawn for a long time. And basically, the way I got into tech was for my 9th or 10th birthday, my grandma, my aunt who was in the US, actually sent me a Nintendo Switch. Not Nintendo Switch, a Nintendo DS. So back in the day, this was like a pretty big thing. And the game she sent me was called Pokemon Mystery Dungeon. For those of you who've heard of that game, you know how fun that game is. And basically, I played that game non-stop. I think I 100%ed the game. And that game made me realize how fun computers can be and how fun programs can be. And that actually sparked my interest into I want to do something with tech. Mainly, I wanted to be a game dev. That was my main pitch coming to college, saying, I want to try and become the best game dev I can. And unfortunately, that did not work out. But we ended up someplace better. So I'm pretty happy with what I am doing right now. And I do game dev work on the side, so there's also that. So, yeah.
Okay, cool. Last question. Oh yeah, Ramika.
Go for it.
It's great to know that you're enjoying what you're doing, but at the same time, is there any pressure to climb those Alps in Google?
I'm going to say no. Do you ever feel pressure that you need to get promoted?
When I wanted to prove it to myself, but
I feel like internally there is no pressure to get promoted. But I also feel like sometimes it does feel that, it makes more sense to try and get promoted to get more responsibility. But I also remember speaking to some people from my team who are like, I'm already at a level where I can just be comfortable with life. I don't want to push and challenge myself higher. And so I'm okay with life, treating me the way it is. And I would say I agree with them sometimes. Like, I feel like everyone's answer is different to that situation. Everyone thinks of corporate ladder in a different way. Some just want to get to the top immediately. Some want to enjoy the journey. And some particularly don't care as long as there is food on the table and a home to go to sleep to and a bed to lie down. So I would say everyone's perspective of that answer would be different. But as for me, it used to be initially that I just wanted to keep getting promoted. But after I took this program, I realized life is not just about going as high as you can and getting the biggest paycheck. No, there's more things to life than just doing all of that. And I feel like GIR at least has made me realize that. So, yeah. While she's typing, anyone else got questions? Sure.
So you were also an international student,
Yes.
right, studying in the college.
Yes.
So how overwhelming it was when you were applying to the intern and while also doing
I will say this right now, half of the positions I wanted to apply to, they did not even accept interns who are international. Most notably JPL. I'm still looking at you, NASA. So yeah, JPL's main requirement, and I'm pretty sure it's posted on their website, is you're required to be a US citizen. And I was like, this is some bullshit. So I will say it is a little bit of a challenge as an international applying for all these positions. But I will also say that I know a lot of internationals who manage to get internship positions, what have you. So I would also say it depends on each person. And I also know that a lot of professors who teach generally do end up having tie-ins with some universities. I know back at UCR, two of our professors, one had tie-ins with AT&T and the other one had tie-ins with Google. So I would say that you should always look up to your instructors and you should always see if they can help you in any way, shape or form, because a lot of them actually can and they will do their best to do so. Okay?
okay, cool. Thanks very much. Okay, if you all could, like the last few days, fill out this form, just so I can give you your homework grade and then be part of that. And then I'll go over reminders as you go. So midterm exam 2 corrections, they're due next Tuesday. So whenever the last TA officers are for that day, no late exceptions for this. And then we're not doing this. Homework, homecoming week. No project, but that will start on next Monday, and you'll have a few more days I've decided to give you on this, so you have till next Wednesday, following Wednesday. And then you have a quiz next Friday. And then don't forget homework 10, this is due tonight. It's just a reflection of all the tech talks that I've been given. And I think that should be it, other than grades and
Wow, you guys do a lot more things than we do.
What do you mean?
Your class is a lot more intensive than mine. You have quizzes, homework, all the stuff.
Yeah, my class is better.
Good.
Okay, how is it going? Good. Okay, so again, I have two Googlers here to talk to you all. Reuben from earlier, I know some of you are from the earlier class, so he'll just come again and do another talk again. But now we have Sam here to come talk to y'all. He works with DeepMind at Google. Yeah. Yeah, give him a round. So yeah, I'll let him do it, and yeah, you can just use the keys to.
Excellent. All right. Thank you so much.
Yeah.
It's great to be here. Good to see everyone. And yeah, excited to share with you all about the kind of work that I do. And I am really excited to hear anything that you have to ask about or anything that you want to like just throw in. I am really looking forward to hearing from you all as well. So yeah, here's a little overview of what it's like to be a research scientist in AI in 2024. So yeah, the day-to-day job is really all about publishing conference papers and deploying algorithms into products. So DeepMind started out as kind of an AI research company. It was very much about publishing papers and just doing things that hadn't been done before for the sake of doing it. So for example, like solving Atari games just from playing them for the first time. That was a DeepMind contribution from about 10 years ago now. And then solving Go was another one. So beating kind of the best human player at Go was another big achievement that DeepMind produced with this kind of very basic research sort of approach. We still do some of that, but I do have to say, since chatbots and large language models and the big kind of AI buzz of the last couple of years, there's a lot more of the second one, deploying new algorithms into products. I kind of work on a small team right now, just 2 to 3 colleagues. I've worked on teams with like up to dozens of researchers, so there's definitely a range in that regard. A lot of what we do day to day is working with like big code bases and kind of isolating like a small component that we think we can make better, making some changes, then running lots and lots of experiments. So we're very empirical. We do a lot of just trying stuff and seeing what works. Just to give you kind of an overview of the field that we're working in as research scientists, we're basically doing machine learning, which is all about coming up with algorithms that can learn from data to make decisions. So a lot of machine learning is trying to find better data, or curate better data, or represent data in a more effective way. And then the other half of it is changing the algorithms, coming up with things that learn more effectively from that data. Nowadays, the term that I hear a lot more than even just a few years ago is artificial intelligence. And I see that as basically a term that's used to refer to some recent very large-scale machine learning systems. So I was kind of curious, do you all use like ChatGPT for your classes? Yeah? A lot? Yeah? Okay. Exciting. Do you think it's been helpful? Do you like it?
Yes.
Amazing. Okay. What about anything else? Claude?
Yeah.
Gemini? Okay. That's really cool to hear.
Copilot.
Copilot? Yeah. That one is OpenAI still, I think, or it's like a Microsoft. It's kind of ChatGPT adjacent.
Yeah.
Okay.
There is Bard too.
Bard, yeah. Yep. Bard. So mostly the chat interface, but maybe a little bit with like in a coding interface, like an IDE, something like that. Yeah. Also generating images. Do you all do any of that?
Yes.
Yeah. Okay. Exciting time. So yeah, this is what we're doing now. Like machine learning has become artificial intelligence, generative artificial intelligence in particular. So today I wanted to kind of zoom in a little bit on a particular class of AI models, the one that I've been working in most recently. Try to give you some sense of how it works in a little bit more of a low-level technical way, and also to give you an example of like kind of a project that I've been working on recently, just so you can get a flavor for what this work is like. So, right, language models, that is what underpins ChatGPT, Claude, etc. And the basic idea is to, let's see if this diagram is going to be helpful at all. I'm just going to step over here. The basic idea is to say, look, we want to, like, we've had a user who's asked us a question, and we want to generate a sequence of words to answer their question. The way that it works at a high level is that you're going to feed in to some architecture, and I can say in a minute what that means. You can feed into your system, your machine learning or artificial intelligence system, the words that either the user said or that you've already output, feed it through, and then you get the next word. So in this word, the dog sat. I don't know if that's going to be an interesting answer in that example, but that's the idea. Then on the next sort of step of generating with your generative AI system, you'll feed the thing you just produced back into your model and ask what should be next, and then you'll do that again with the output of that, and so on and so forth until you generate, hopefully, some really useful response to what the user asked you. Sorry, did you say something? Okay.
It's a pleasure.
Oh, thank you. And if anyone has questions, feel free to stop me. Right, so how do we actually take those previous things that we generated or the question that the user asked us and generate some sensible output? It basically comes down to neural networks, which is a term that might or might not be familiar. Have people heard that term? Is that, yeah, a little bit?
Yeah, a little bit.
Okay, so ChatGPT, everyone knows about neural networks. Maybe some people know about. I'll just give like a really quick overview to hopefully give a sense of what they are and what they do. So it's kind of inspired by the brain, very loosely. The idea is that you're going to have like a system of connections between units that will be represented just as numbers, and you're going to be able to feed your data through those connections in order to produce an output. So more concretely, in the case of like generating language output, you can represent your words as like vectors, which vector is just like kind of an obscure way of saying a list of numbers, just a list of numbers, let's say between -1 and 1 or something like that. So you could say, if I have the word dog, instead of representing it as dog, I could represent it as a vector with like 30,000 numbers in it, which will all be 0 except for 1 in a particular position. And whenever that position is set to 1, that represents the word dog. And I could do that with all the other words that are likely to come up. And then I can say, great, I've represented words as numbers. What we'll do then, if we want to say we have a sentence that started with the dog and we want to get the next word, let's say the next word that existed in some web page or in somebody's Twitter post or something when someone said the dog and then the next word. The way that we could try to make that prediction of what comes next is we can create a bunch of random numbers and put them in matrices, which is just a way of saying we have like, you know, a bunch of numbers set up in the shape of a square, and we can just multiply that vector representation of dog through a bunch of these matrices of what start out as just random numbers that we just pull out of a hat that define some function. And we can get some other number on the output, and we can then say, well, what we wanted on the output was the word for, or the number representing the word sat. We didn't get that at first because they were just random numbers, but we can take the thing we actually got and the thing that we wanted, and we can use the chain rule from calculus, which might be pretty familiar. Not anything too complicated, something that you'd likely learn about in high school or maybe in the first couple years of college. Just take that, and that'll give you a way to just tweak all of those random numbers so that you're more likely to get the thing you wanted on the output. You're more likely to get that vector that's all zeros and just a 1 in the right position, that means sat. And basically you just keep doing that with a huge amount of data, and you get the thing that forms the basis of ChatGPT, which is kind of crazy. It's mind-blowing that that works. And that's kind of what this XKCD is about. I don't know, does anybody know XKCD? Definitely check it out. It's amazing and hilarious. It's basically a bunch of nerd jokes. So this one is kind of pointing out how amazing it is that this process works, that you can train these systems in this way. So the joke is like, someone says, this is your machine learning system. You just pour the data into a pile of linear algebra. That's just a way of saying, another way of saying all these random numbers that you're going to do multiplications through. And then the person says, what if you get the wrong answer? And it's just like, well, you just kind of tweak the numbers. You just stir it up until they start looking right. So that is what neural networks are. So if you are ever wondering, how is ChatGPT working? What's it doing? It's based on neural networks. That's what they do. That's how they work. In particular, ChatGPT uses transformers. So that's the T in GPT. And that's a particular type of neural network. Nice. All right. So the transformer is basically a way of putting together a bunch of neural networks. And I'm not going to dive into the details of this any more than just to say all of these little boxes are just different ways of putting those random numbers together, multiplying them together in different ways. That's essentially it. So I hope that people have a sense of what these systems are doing from your own experience working with them, and now some kind of idea of how the sort of math works out so that these things can be trained to do the things that you see them doing. Now I'll just take a look at kind of an example project, something that a researcher like me would do in the course of a few months working in this area. So this project was called Mixture of Depths, was all about making the transformer model more efficient so that it would be cheaper to train. I don't know if you all have seen headlines about how expensive it is to train ChatGPT. It's many millions of dollars to train one of these things. It's pretty staggering. Microsoft just signed a deal to buy a nuclear power plant just to power the data centers for training these things. And I think Meta was trying to do that, but then there were some bees on the...
Google has also done it.
Did Google do it?
Yes. Amazon and Google have also recently joined the nuclear power race.
Yeah. So it's a big thing. These things are incredibly expensive to train, and it would be better for the environment if they were less power hungry. So one thing that many of us would like to do is to make them require less power. We still want to be able to provide the same capabilities that they currently do and improve them, but more efficiently. And also it'd be nice if they were faster. We could just serve them on phones more effectively and just provide more value by giving answers more quickly. So that's kind of the goal of this project. So in order to explain what this project is about, I just need to point out one other thing about transformers and systems like Gemini and ChatGPT, etc. So the transformer that I showed you on the previous slide is just one in a whole stack of those transformers that you would get every time you press Go in Gemini or Claude or whatever. You're going to be running a transformer block like that, but you'll run 20 of them in a row where each previous block produces something that the next block takes as input to get to produce an output for the subsequent block. And you'll do that for 30 blocks or 70 blocks or something like that. So what that ends up looking like is something like this. If you feed a sentence into one of these language models, then you'll end up having something like, if you say Google DeepMind has offices in these locations, each one of those words, more or less, will be converted into one of these number representations, which I'm going to start calling those tokens. Those number representations are in this transformer setting, often called tokens. You'll end up with one token for each word for each of the transformer blocks in that stack. And so basically for each one of these little squares, you're going to have a bunch of numbers that need to be represented and and in order to get from one block to the next one above it, you're going to have to spend a lot of compute. You're going to have to use a lot of energy to do those multiplications by all of those random numbers in order to get the next blocks out. So the key idea in this project was to ask, could we actually just get rid of some of those? Right? As we were saying, these systems, they start out just as random numbers, and you're just passing stuff through them, getting some output, and then training that whole thing to give a better output. So do we really actually need all these things? Why not? Maybe we can just get rid of them and still perform really effectively, subject to some costs that we're paying in order to produce the output. It turns out that if you just do that naively, it doesn't work super well. If you just cut things out, you get bad results. But if you kind of learn a router, or you learn a function that will look at each one of those tokens, look at each one of those blue boxes and say, actually this needs to go through, or you know what, let's just skip this one, then you can get really good results. And you might wonder, well, how are you going to do that? How are you going to automatically look at these number representations and decide whether or not it needs to go through? And the answer is that you do the same approach that we talked about before, the same kind of neural network approach. You start out with random numbers that you're gonna multiply those representations through, and you just learn a function by the chain rule to basically optimize your output. And it turns out that works. You can learn a router like that and get really good results. So just to give you a sense of what kind of the outcome of the project, well, not really the outcome of the project, but what kinds of metrics we look at to see if we're succeeding. Here's kind of an example plot from the paper about this. So what we're seeing here on the y-axis is like the loss. So that's basically the difference between the thing that the system output and the correct answer. So you're just basically measuring that delta, literally just a subtraction and a square. Or maybe, yeah, roughly you can think of it like that for the purposes of this talk, because that's basically the idea. So you basically want it to be lower. If that thing goes all the way to 0, then you have perfectly matched the output. And what we basically see is like our thing in blue here is getting lower than the black, even though it's spending a lot less compute to do it because we skipped all of those blue rectangles, right? So we're really happy with that. Just one other thing maybe I'll point out briefly about this plot that we can see is that we're running these models at different scales. So this is like a relatively small model, this is a bigger one, this is a bigger one, and the loss gets much, much less as we scale up. And in fact, these are all very, very small models, like a couple % of the size of the thing that you're getting when you run Gemini or ChatGPT. So a lot of what we're doing here is looking at this trend and extrapolating. What if we go way, way down to a huge model and asking like, if we have like a small win from creating this efficiency boost by cutting out this computation, can we extrapolate that to like, really massive reductions in the electricity that it requires to provide responses when running a big model like you get when you ping Gemini or ChatGPT. Right. So that's the most technical that we're going to get. And even if some of it made no sense, that's okay as long as you get kind of a feel for what this is like. Before I jump to the next thing, does anybody have any questions or comments or complaints about any of that? Yeah. Go for it.
Question. First of all, maybe I skipped it or something like that, but like how, in any sense, are the responses that the AI generates, are they coherent? Are they like something that, I remember for this stuff like it's, at first like all these generating images and all like that, at first, when like the first one is come out, you could pick between it being coherent, the images being like sensible.
Yeah.
And then you could also pick like incoherent, like just anyhow.
Yeah.
And so like also in like language and how can you like how do they follow grammatical standards and like all like the other stuff?
Yeah. So you're asking like how do we get models that have coherence, or are you asking if we have a model that doesn't have it, how can we fix it?
Well, like how do you make your models coherent? Like,
yeah. So it's another one of these really amazing things, kind of like this business with the chain rule and the random numbers. It just kind of happens almost as a surprising fact of life, that if you just train these things on enough data, they will start to be coherent. So if you just scale it up so that you're training on all of, or a really large fraction of the data, of the, let's say, language data that exists on the web, or the images that you can scrape from the web, then you're going to run your whatever input through those originally random numbers that you've trained that way, and it's going to come out looking like something sensible. It will look reasonable. Then there's another question of like, how can you get it to output something that's useful to you, which we could talk about that. That's a lot more of the same kind of stuff. But yeah, it's sort of an amazing fact that you just train the language model on a bunch of stuff people said on Twitter, and then you just ask it to generate based on its own previous output, and it makes sense. It generates coherent language. Yeah. Sorry, I wish I could answer that in some other kind of way than that, but that's just the fact of it. Yeah.
So with stuff like ChatGPT, right? Sometimes you get these errors, like there was this one popular thing that circulated around Twitter. If you asked it how many R's are there in strawberry, it would say something like 1 hour. What sort of causes like the discrepancies in that big of a model?
Yeah, that was a really interesting one, and just by total random chance, I happened to see, I think it was in a blog post, or maybe someone from OpenAI had said something on Twitter about that in particular, and that was something to do with their tokenizer. So y'all might remember that when we were on this slide, I was saying like, oh, when you input your sentence to the model, you're going to take each word and put it into and represent it as numbers. Yeah, that's going to be a token. And I was like, it's a word more or less. It's not exactly a word. In fact, there's something called, or there's a process called tokenization where you'll take the sort of raw language and you'll split it up in some way. And you might actually split words in two, like you might say, mountain, that's better separated into the two syllables, mountain, for example. Or something like Google DeepMind might be combined as if that's the single one. And so in the case of that strawberries issue, the way that their tokenizer worked was making it so that like the whole, I think the straw part of the word, I guess, maybe it was the straw or the berry part of the word, whichever one, was just represented as like a single, like it was represented as a kind of atomic thing. And the model didn't have any access to know, oh, that is made up of, B-E-R-R-Y. It just had berry, that's it. And so, yeah, in that Twitter post, the person kind of said, if we train it with a different tokenizer, then it works and it gives the right answer. And I think they might have deployed that because it started behaving more effectively in that way. So yeah, that's kind of, I feel like a lot of times when things aren't working, it's something really low level like that. Yeah.
What's your mathematical background?
Mine. I'm gonna do a little section on my background, so I'll say something about that and then come back to you. Yeah.
So when we prompt ChatGPT or Gemini something, so while we prompt a whole bunch of keywords and stuff, sometimes we don't get our desired things in the output, right?
Yeah.
Is that because the neural networks are sabotaging themselves because they don't have enough optimized routers, or why is that happening?
So you're saying you have to get the prompt just right in order to get a useful output?
Yeah, we have to ourselves train the GPT or Gemini, giving them bunch of reference to what we're talking about first. Then are they gonna make their some sort of their own optimized routers? Then they're gonna look through all these chains on the neural networks. How does it work?
Yeah. So basically, at the very start of this whole process, if we've just trained exclusively on web data in this way that I've been talking about, where you just try to predict the next word, if you put in the prompt, it will just probably generate something totally unuseful. And what needs to be done then is to train the system, as they call it, fine-tune it, by having people ask you questions, get an answer they're not happy with, and say, actually, I wanted something more like X or Y or whatever. And then you do more of this kind of training so that then you can put in prompts that you expect to work and they actually do work. So when you see that it's not quite working, I would see that as a case of just requiring more work on the part of the companies to get prompts like yours, train the thing to give a useful output for you. In the meantime, we've got prompt engineering, which is a big thing that you guys, have people heard about prompt engineering or had to do it yourselves? Yeah. In the meantime, we just have to try to hack it and do the best we can with the way that they're fine-tuned at the moment. Yeah?
Yeah. You said it's very expensive to establish and train these models, but then it's free available to everyone to use. So how does the company themselves make money? And are they just using us as, are they providing it to us free so that we can train the models for them?
Yes. So it's a really interesting area. So the way that things are funded now is venture capital and just big tech companies have a lot of money. They think they're going to be able to make money off these systems in the long term, and so they're willing to take massive losses over the course of a few years. As to whether or not your data is being used to train the model, I think it really depends on which system you're paying. I've seen that actually a lot of companies are not training directly on the queries that users that come from users. They're instead taking other approaches like paying raters, like paying people whose job it is to prompt the thing and see that they didn't like the output and give a better response. So as to that part, I think it's sort of complicated and probably depends on which company, what time is it happening, etc. Yeah, just you. I don't have a sense of the time on this.
No, it's okay. I think you're good. I
Just
want
keep
to
going.
prioritize your
Just keep going.
talk. So
Are
keep
you sure?
Just keep going.
Yeah.
Okay.
Yeah, a lot of them I've seen Reuben talk already. So.
Just keep going.
Okay.
You do your thing.
All right, you just let me know.
Yes, I'll definitely know. Thanks for letting.
If anything, they can just meet me up after. Mine is not as interesting as yours.
No, but I know
Sure,
that they
that's not
all
true.
were really
Okay.
looking forward to your talk, so I'm glad that they all have questions. So yeah.
Amazing. Yeah.
Just keep going. Just keep going.
Okay, great.
Don't mind
I think I saw your hand.
Okay, yeah. So like for like regular like libraries like for like PyTorch and like Scrivener. So like, do you like someone like with DeepMind? Like, do you guys like kind of like leverage on those tools? Like, do you guys have like tools now? Because like, I mean,
Yeah.
for like regular people to like do stuff, you kind of leverage on that too. So like, unless like I have to create something to do everything every time, like do the metrics multiplication every time. So like, and I don't have to do that all the time. Now we have like all the libraries. Then like, do you guys like use those ones? Or like, do you guys have like more like specialized ones that like are more optimized for your high skill?
Yeah, I would say that it comes down to like a decision on the part of like specific companies. So Meta in particular has made like a big commitment to like open source code and also like kind of available models, even like model weights being available. And so for Facebook, they are using, I think, still PyTorch. I think internally, as far as I know, they're still using the external PyTorch that you would be able to use. Google and DeepMind have taken sort of a different approach and have open sourced some things, but so there is JAX public. There's a public JAX, and it shares a lot of features with the one that's used internally, but there also are just a bunch of changes that are specific to kind of the Google software stack and hardware stack as well that aren't kind of made publicly available. So I think OpenAI, they don't really put a lot of stuff out. Anthropic doesn't put a lot of stuff out. It just depends on the company. But I definitely don't think there's a difference in like skill level or quality of the systems. I think the open source code is great. I haven't seen any evidence that it's less great than what's internal. It's usually just what's internal is more bespoke. So yeah, just there'll be a particular sandcastle inside of Google that has particular features that might be different, and that's what you're not getting. Nothing in terms of overall quality.
Another question.
Yeah.
Also, so like kind of like there is okay, so like regular like so like when you use like those libraries in like Python, basically like Python is like object oriented, right? So then like stuff like JAX isn't like object oriented. So like does do companies like have like different approach? Because like I mean like for like JAX like Python like more object oriented, and then like JAX actually does more like stuff like with like functions and more So like do companies like have prioritized which approach to pick, or like they are agnostic? So like as long as like something works, like just move with it.
Yeah. My experience has been that the companies do have a pretty strong philosophy about these things, and even like internal to a company, there can be like one group that's like we're using JAX, and another group that's like we're using TensorFlow, and they have very different strengths and weaknesses, and it ends up being kind of a bit of a battle between the two like kind of design hypotheses, and you just see which one wins out based on who has more users, whose products are working, and whose products aren't. So yeah, there's a bit of a bottom-up and a top-down kind of. There both of those processes at work in determining whether you get JAX or PyTorch or TensorFlow. Yeah.
So you said that the user is like the most that user passes on this transfer into software that is used to operators So how is that process? How is that process done? Like, is it that for each one is each one is given software developer, and then whether or not to this process how does it work?
Yeah, so basically the way that it works is that each word is given, I don't know if I have anything about this here. Each word is basically assigned a number, and that's what this input embedding is on the very lowest layer of that kind of stacked set of transformer blocks. It's literally just like you decided by fiat at the beginning of training that dog is going to be represented with the 1030th like number in your vector set to 1. That's done. And then the rest of it's just learned. So on all the subsequent higher blocks, they just take whatever the previous block output, which is initially random, and then they just tweak it over time to be useful. So yeah, basically you define the bottom, the rest of it just sorts itself out.
And is it like something that's also, is it something that's the engineers will sort of like change with time? Because like, I don't know, can you have like one system about all these?
So you're asking like, can you have one system to cover like lots of different tasks or different?
As rules to representing what as this sort of numbers, do you, is it the system needed to like transform the most? Is it like edited with time?
Yeah, sorry, can you say that last part again?
Like, is the system that changes the user input to numbers, is it edited or changed with time?
Oh, like manually edited? No, not at all. It would be, there's so many numbers, it would just be, like you just couldn't think about it. Like, it would be totally unintelligible. And the way that you would try to change it is to change the architecture. Like, there are some things that, yeah, we could chat offline about some of the things that you can change to shift the representations, but mostly you're just looking at the loss. So those curves that we were looking at where we were seeing the difference between what we wanted and what we got, mostly it's just looking at that and changing things to make it better. Yeah. I'll do one more and then maybe I'll go through the rest of the day.
Yeah, I think Toyosi has been waiting, and then maybe you can do Reuben, so those two.
Okay.
questions.
Yeah.
Sorry, I know you probably have somewhere to be as well.
No, it's okay. I'm good. Yeah. I'm
Okay.
good. Yeah.
Toyosi, yeah.
So about the prompt engineering.
That's
sorry.
No, Toyosi, you ask your question.
Sorry.
Toyosi, you go.
I just want because you said the aim of what you were doing was trying to see if you could skip some blocks,
Mm-hmm.
but then you had to build an entire process. Doesn't that take energy as well? And how, if it takes less, why?
Yeah, that's that's totally on point. So it does take a little bit of energy, but it's just a lot less, and it's because let me see. Yeah, maybe this is a good way. So basically, our goal is to skip this whole thing, and this in particular, let's say the feed forward is like the number of numbers that you have to multiply through is like astronomical, especially in like the production models. And then in the case of this multi-head attention, you're basically also taking a bunch of the tokens from your history, like tens of thousands of those tokens, and multiplying those through functions, through initial random numbers. And that's super expensive. When we compute the router, it's just a single, what we call the linear layer. So it's just one number for each one of the numbers in the token that represents the word that projects down to a single scalar, a single number.
How does that work?
It's amazing that it works. It really is. Yeah, I think it's basically because you have, like the token representation is the result of all the previous layers, which there's a lot of parameters, a lot of these random numbers that produce that. So they can shift quite a lot to make it so the router can just multiply a single value by each one of those values, get one number, and you just threshold that number. If it's below 0.5, you're not going through. If it's above 0.5, you go through. So it's very cheap by comparison. Yeah. Very nice.
Understand. One more Rockin' and then
Okay, so in the recent presentation by OpenAI, they compared the GPT-4 with a small fish and GPT-5 with a big whale. So how does AI grow so exponentially? Is it just feeding more data or something else is going?
Yeah, so the data is a big part of it. There's been a lot of talk that maybe data that gains from adding more data is saturated. So then there's also gains possible on the side of making the models bigger. And there's gains on the side of training the model more on the same data. So yeah, I would say basically you're on point about the data amount. The other one to add is the model size. And then of course there's data quality is really important. And then the algorithm use, so basically the model quality is really important. So those latter two don't really scale with energy costs directly, the first two do. And that's kind of the situation we're in now. Yeah, nice. All right, thanks for all the questions, that was amazing. Let me just go through just a couple of like kind of career things, and then if there's time, we can go through some questions on that.
Yeah.
Right, so yeah, I was just going to say a little bit about the workflow of what this job is like. So for that project in particular, what we had to do is basically read papers, me and my two colleagues basically, lots of brainstorming, just discussions, what would this do, maybe that thing could work, and just trying some things, seeing if they work at all, and if there's a little bit of daylight there, then pushing more on it. So in that regard, there's coding to implement these kinds of ideas. Like we had to write some code to drop out those squares that we looked at, and then just running lots of experiments because there's lots of little details that make all the difference between these things working and not working. And then once you get it working, if you're lucky enough to do so, then writing a paper, giving talks, discussing. So that's basically the job description right there, the kind of day-to-day. I just wanted to say something quick about how I got here, which maybe connects to that question about the math background. So I started out very much not doing math. I was studying music, actually, and then I got interested in cognitive psychology. And when I graduated, I needed to pay off some student loans, so I just got like a software development job and really liked that. So then I took that kind of interest in psychology and interest in programming and worked at a neuroscience lab for a year. That kind of got my foot in the door to do a PhD in neuroscience, studying kind of how does language work in the brain, or how might language work in the brain. And then also during the PhD, I needed to transition to studying like reward-driven learning. So very much like the reinforcement learning systems that solve Atari or Be the Best Human Player at Go, like studying those kinds of systems and asking like how might different structures in the brain implement some of the key elements of those algorithms. And then from there, I started working on deep reinforcement learning and this generative AI stuff now at DeepMind. So yeah, you're asking about math background. Basically, I am perhaps a little bit unusual in that I didn't really do a lot. I did very little, mostly just did statistics stuff in high school and college, and then it was mostly like self-study, and then in my PhD just like kind of building up those skills wherever I could. I would definitely say if you're interested in a career in this area, learn as much calculus, linear algebra, probability theory. Not necessary to go into like abstract math unless you like it, so like group theory or topology or something, probably not going to help a lot. Maybe I'm going out on a little bit of a limb there, but I'm just going to say it. I think those other topic areas are going to be the most useful directly for this kind of stuff. Right, so yeah, kind of in line with what I was mentioning just there. If you're interested in this kind of stuff, coding, those particular math disciplines, unless you want to study abstract math, I'm not saying don't do it for fun.
It's very fun.
It is. Yeah. There we go. Yeah, also, I would say like just experience in experimental science, which is something that, maybe I do see that there's sometimes a dichotomy between the people who really want to go for the abstract math and the people who are really coming from more of like, I just really love doing experiments with complicated systems and seeing how they work. Getting your hands dirty versus being abstract, I feel like it's always a bit of a trade-off, but I feel like I wanted to highlight the experimental side of things.
I have a very common question which I think all these people will have. When you started off, were you any good at any of these?
I mean, maybe the question is, am I currently any good at any of these? I think no. I think would be the answer, especially, and again, I might be a little bit more extreme than others in this regard. Like I really was coming from studying music and psychology and things that did not involve really any of this. In psychology, we definitely were working on experiments, but I think it was very much a matter of being in my senior year of college and realizing I really, really liked coding and running with it from there, more than it was being like, 8 years old and being like a coding prodigy. So yeah, I would say, very much a nurture over nature argument here. Oh yeah, scientific writing and communication also important. Yeah.
I'm so sorry. Just like you said, you liked you like really had a knack for coding during your senior year.
Yeah, I had an interest in it.
I had an interest.
Yeah.
So my question is how you were able to get a job in software development.
Yeah.
With that period of time.
Yeah. It was definitely like an attempt at being strategic to make like a lateral move. So the job that I got was like, it was like a management track job for tech projects. So they were hiring me because I had a background that would be suitable for being like a, what do you call this, like a management consultant at like Bain or McKinsey or something like that. Because they're just like, we want somebody who got good grades and any major. But these are going to be tech projects. So then I was able to kind of like leverage the, yeah, exactly. Kind of leveraging the skills I did have to get into a situation where I could get the skills I wanted.
Yeah. With how abstract like large language models tend to be, like between their implementation and their outputs, do you ever find yourself getting lost in that abstraction, and how do you pull yourself out of it?
Yeah. Definitely it's easy to get like lost in the wrong sorts of details or the wrong kinds of abstractions. I think recently, like in the last few years, I've really been trying to focus on like the learning curves. Like we were looking at those curves before where you're just looking at the loss. Yeah, really focusing on that and looking at your code and figuring out like what are the code changes that make the changes in that loss. And let me not go down too many rabbit holes of like exactly how are these representations, like these numeric representations looking. Like you were asking about, you know, do you ever shift those manually? And definitely when I was in neuroscience, like we would think about that kind of stuff. We'd be really interested in like, what do these representations look like? What are their properties? Maybe we can analyze them, et cetera, et cetera. And now it's like, don't worry about that. Just like focus on the learning curves, get the, and also now focusing on like, are users happy? Is the model safe? Is it like, you know, consistently giving correct answers? Just like focusing on those outputs helps with that. Yeah. Nice. Let me see if, yeah, basically email address there. Happy to answer any more questions now, depending on time.
Yeah, we have a few more minutes, so yeah, if you have questions.
Yeah.
I wanted to ask about, so you guys are building AI, you're probably going into AGI now, artificial generative intelligence, right? So
Yeah.
how much of AI is actually helping you build AI, if you get my drift?
Yeah. I feel like,
I can take a stab at it if you want.
yeah, go for it, yeah.
So as far as Google Cloud is concerned, we got access to our internal version of Gemini, which is Gemini is our ChatGPT equivalent. And our internal version is decently smart to the point where it can do all of our autofilling for us. And it is decently smart enough to understand pattern recognition. But as far as interesting ideas and, you know, starting from scratch goes, it is far from it. So it is very good at pattern recognition. And let's say I wanted to copy paste a few things and change a few numbers up, right? It would copy paste it exactly how I wanted to and change the values for me. So I would say that it is decently smart, but it's not smart enough so that it can replace us. It is smart enough to do rudimentary operation. At least that's how our internal system goes. External, well, that would be back to you.
I agree with all of that. Like, I wish they were better. I feel like they could be a lot better, and it's just hopefully in the next year or so we'll have much better developer tools. And yeah, like you were mentioning the idea of like replacing, like, you know, let's say
We're far from it.
Yeah, very far from it, but not. I would definitely not rule it out as something that, as something that would happen. That the kinds of things that I was mentioning as my day-to-day might no longer be my day-to-day in 5 years or so.
I do feel like software engineering is a field right now whose job is ever evolving. And I also feel like our job responsibilities are constantly changing over a period of time. And AI is definitely speeding up that process. So what we are doing right now, maybe in 6 months we will not be doing, we'll be doing something else. It's pretty uncertain, but that's the beauty of it, isn't it? Yeah. That's the fun part about our jobs.
Sometimes the scary part. Also.
That is also true, yes.
So, in regard to the deal with NVIDIA and OpenAI, how much is physical infrastructure limiting limiting the development of AI right now?
Very much. Very, very much, I would say.
Let me ask you this question.
Yeah.
You have your computers with you, right? All of you have your computers with you. Let's say you wanted to run a training model of this caliber on your computer. How long do you think it would take to train on your devices?
A year.
10 million.
A year?
I'll say 10 million years.
10 million years, sure. It would take a decently long time, correct? Now these are devices that are made commercially available to students like us as creators and so on and so forth, right? The ones that get utilized in AI are very specialized models which have maybe 100 times capability. Maybe even more, maybe less. I'm not entirely sure, I do not work in that division. The point is that because they are very specifically made, they require a lot of architecture and construction to make, and so we cannot mass produce them like how we mass produce the laptops we have. Due to that, that is one of the main points that leads to the inability of us to develop this really quickly. If we had this ChatGPT and AI models being able to run as fast as we can on our personal laptops, we would be able to increase our production by 15-fold.
Okay, we have time for one more question. Is there someone that hasn't gotten a chance to ask yet and wants to ask a question? Yeah. Sujal, go ahead.
So I wanted to ask, how is Gemini, working in Gemini, different from working in ChatGPT, and how internal things work? Are they
They're different companies.
Are they using different numbers of transports, or how is overall model that how are they different?
Yeah, so you mean how does ChatGPT different for Gemini, or how does working at OpenAI different from working at? Yeah, I have the sense that OpenAI is very targeted. They were very targeted about large language models, chatbots, AGI, get things out, a little bit of move fast and break things from my perspective. Whereas Google does so many different things. They haven't been focused specifically on that in the same way. So all of these products that we use, your Gmail or whatever, all the Pixel stuff, there's very much more of a focus of getting the current technology into Google products. Whereas at OpenAI, I imagine there's more of a focus on we're just trying to scale this, get the next massive breakthrough. That's my perspective on it. Maybe other people would have a different perspective. Yeah.
I would say that ChatGPT, at least the people that were behind the creators of it, their focus was to develop the first true chatbot that can answer any question you give to it, correct? The ones that at least have come up at Google have been, I would not say a imitation of it, but Google has done its own separate way of going about this whole AI boom, right? So I would say that they serve different purposes, but in the long run, they're both trying to achieve the same thing. One is obviously, it was independently made and now it's co-owned by Microsoft, and the other one is obviously co-owned by Google. So they have their own trade-offs and they have their own way of looking at it. And to the point of, currently our focus is to get into our products. How many of you have actually used Word and used the Help Me Write feature? Is that GA yet?
In Word or in Google Docs?
Google Docs, sorry. The Help Me Write and all the AI components. So you guys experimented with them yet? So as you can see, right, our focus, at least as far as I'm aware at Google, is that we're getting that into our products. I cannot speak for OpenAI because, well, I don't exactly work there. So.
So, I'm sorry. So
Okay, last question.
No, it's okay. You said these language models are getting improved, and Google is trying to implement these models on their product. So later on the later future, let's say you have a very improved model and you have implemented all these models onto your product. So the general people are the general people gonna be affected with this implementation, because it's gonna be really good model implemented in the current product. So are the current general people gonna be affected with some charges to get these features on the current model, current products?
Yeah, I would only be able to speculate wildly about those business decisions. I don't know.
I don't think we as developers can talk about what's going to happen in the business end of things because frankly that is mainly out of our control. What I will suggest right now is a lot of companies do this thing where they have a free version and then a pro version that does higher capabilities, correct? And I feel like that freemium model, as like people like to call it, will probably continue on with the capabilities that we have today. So I would not see it changing, but again, this is from people who work internally. We do not make business decisions, and we have very little say in the business matters. So I would not be able to give a concrete answer to it.
Okay, for real, one final question. Ramika, one more.
How do companies like Google avoid perpetuating biases while working with large data sets?
Oh, that's a great question.
Yeah, I think it's such an important question. It's a lot of work. I think it's a lot of people looking at the model's outputs and flagging cases where it said something inappropriate, and then feeding it back to this pipeline where you'll kind of construct a bunch of inputs that could elicit a harmful response, and then somehow, by one means or another, creating sort of appropriate responses to those inputs, and then training the model on those responses. Just in the same neural network training way that we talked about before, you just do the same thing with new data that you generated specifically to be about that case of bias that you identified. So it's basically more of the same neural network training and a lot of just people working hard on it so it doesn't do harmful things.
I do have a little fun story to share regarding bias. Before it was called Gemini, it used to be called Bard. And before Bard was first, I went into during its public open beta, it was apparently too conscious of bias. And some of the news articles that came about were really funny. So I would encourage some of you to look it up if you want to see if Google is biased or not. I would say it's a little too biased if you've read any of the articles. But I think it has been getting better over a period of time. So if anything, it can only improve. So.
Okay, cool. Yeah, great question. Good question. Okay. I know you probably have somewhere to be your top places to go, but I will share Sam's slides and his contact info if you have any questions. And just to wrap up, feel free to cut out if you need to, and I'll let you know if there's any questions. I'm sure they will reach out to you.
Yeah, exactly. Just to second that, you can get my contact information from the slides. If you're curious about anything, happy to chat.
Thank you so much.
Right.
Thank you so much for coming all the way here. Sam's the best, huh?
Yep.
Okay, so I know technically class was canceled, but if you all want to, please, I'm not saying, or I'm asking, please fill out the form so I can track your attendance and just give you a grade, and then also just let me know your thoughts if you want me to also share anything with Sam. But fill out the form if you can. I probably won't, honestly, do this today. Yeah. I hope.
How do you want to share two different things?
Oh yeah, you could, if today was your favorite, if you had thoughts about today, you could share the same thing in the form and the homework, yeah. Was that your question? Oh, sorry. Huh?
Before us, we had to take
Yeah. Oh, yeah. You can put the same thing or leave, or just put scribbles, just write something random. Yeah. Vijay.
Did you require to fill this if you fill this in the morning?
Oh, no, if you already filled it out, that's fine. Yeah, I would say Same question? Okay, yeah. And I'm sure you all have heard me say this already, but midterm corrections, you have a few more days to complete that. And then, ignore that. There will be project 2, part 3 released on Monday, and I think I'll give you a few extra days to do it. So you'll have until Wednesday. Make sure to read the instructions carefully, okay? And then homework 10, don't forget, is due tonight, so just a reflection on the Tech Talks this week. And have a great weekend. Have a good homecoming weekend. Yeah, let me know if you have any questions, and I will share all the slides and recordings. I'm just asking all the people who gave talks to make sure that it's okay for me to share it with you all. So that's what I'm double checking. But there are some recordings that are available here. So thanks again for being so attentive and being so respectful to all the people that I've given it. Thank you guys. Okay, yeah, let me know any questions, and have a great weekend.